Sir, you are not audible.
Sorry, let us restart. So, good evening. So, in previous class, I have given you idea about the how to generate the discrete random variate. Now, I will start the how to generate the continuous random variate. So, here, given the random number u between 0 comma 1, a random variate x can be generated as follows. So, what is the what is here given to you, that u is what uniformly distributed number between 0 and 1, 0 inclusive, 1 exclusive, and fx is also, fx is what, cdf. Fx is the cdf. So cdf also lie between the 0 and 1 because it is the probability. So it lie between the 0 and 1. So when we make the correspondence between u and fx, because both are in 0 1, so we can make the correspondence by equating it. So u is equal to fx. So here the random variate x you can generate as a f inverse of the u. F inverse of u, where u is what, random number. Where u is what, random number. So in this way you can generate any continuous random variate. Just you have to equate the cdf with the cdf with the u and take the inverse. So that is the method of the inverse transform. So let us have this example. A continuous random variable x has the following PDF. Fx is equal to minus x cube. In this example, fx is given to you as a minus x cube minus 1 to 0 for this range, and it is the x by 2 from 0 to 1, x by 2 from 0 to 1, and it is 1 by 2 from 1 to 2, 1 by 2 from 1 to 2, and it is the 0 elsewhere. So any random variable, which type of the random variable? X, a continuous random variable having the following probability distribution. So when we have the following, black is okay. Black background is okay.
Yes, sir.
Yes, sir.
Yes, sir. So when we have this fx, so how, in the very first class I have given you the idea how to compute the cdf from the pdf. What is the basic definition of the cdf? It is the integration from minus infinity to that point, right? Accumulation of the probability up to that point of the fx and with respect to x. So fx into dx. So it can be when the x is less than, when x is less than minus 1, when x is less than minus 1. So when we compute the minus infinity to x, so at that time integrand is 0. So 0 dx, so result will be the 0. Result will be the 0 when x is greater than minus 1 but less than 0. Greater than equal to minus 1 but less than 0. So it will become minus infinity to x. So that can be written as minus infinity to minus 1 plus minus 1 to x. Minus 1 to x. So just now we have seen this result is 0, and here we can write it as a minus 1 to x, and in this integrand is the minus x cube into dx. Minus x cube into dx. So this can be written as integration minus x to power 4 upon 4 and minus 1 to x, minus 1 to x. So this will give you 1 minus x to power 4, 1 minus x to power 4 upon 4. This only, no? Yes. 1 minus x to power 4 upon 4. So when we have this, so when we put the x is equal to 0, x is equal to 0, this will give you 1 by 4. 1 by 4. Now, similarly, if we have to compute for the x greater than 0 but less than 1, so it is the minus infinity to x, right? Minus infinity to x, that can be written as minus infinity to 0 plus 0 to x, 0 to x. And just now we have computed, right, from minus infinity to 0, its value is equal to 1 by 4. Generally in exam, students forgot to add this, so you have to add up to the 0 what is the value, up to the 0 what is the value. So 1 by 4 plus 0 to x, and for this interval integrand is, for the 0 to x, it is the x by 2. So 1 by 4 and integrand is the x by 2 into dx. So 1 by 4 plus integration x square by 4 and 0 to x, 0 to x. So that will give you 1 plus x square by 4, x square by 4. So when we put x is equal to 1, x is equal to 1, it will give you 1 by 2, 1 by 2. So when x is greater than 1 but less than 2, when x is greater than 1 less than 2, so this will come minus infinity to x, that can be written as minus infinity to 1 plus 1 to x. And for the minus infinity to 1, it is the half plus. Now for the 1 to x, for the 1 to x, integrand is 1 by 2. Integrand is the 1 by 2. So integration 1 to x of 1 by 2 into dx. 1 by 2 into dx. So it will be the 1 by 2 plus x by 2, x by 2, 1 to x. X by 2, 1 to x. So it will give you x by 2 minus 1 by 2, and minus 1 by 2 will cancel out, so it will become the x by 2. So when we put x is equal to 2, x is equal to 2, this will give you 1. So when the x greater than 2, when x greater than 2, so this will become minus infinity to x, minus infinity to x. So that can be written as minus infinity to 2 plus 2 to x, 2 to x. So for this it is the 1 plus 2 to x 0 dx, because elsewhere integrand is 0. So this will give you 1 plus 0, that is the 1. So from here, if I write the fx in fair form, when I write the fx in fair form, so first it is the 0 when x is less than minus 1, and it is 1 minus x to power 4 upon 4. 1 minus x to power 4 upon 4 for the range x from minus 1 to 0, and it is for the range from 0 to 1, 0 to 1, this is equal to 1 plus x square by 4, 1 plus x square by 4, x square by 4. And for the x greater than 1 but less than 2, it is the x by 2. And for the range x greater than 2, it is 1. It is 1. So very important thing I am going to convey here. Please listen carefully. When we are writing the CDF, whether in operation research or in the probability, right? When we are writing the fx, right, when we are writing the fx anywhere cdf, always there must be the 0 to 1, because you know the fx range from 0 to 1. For the x from minus infinity to infinity, for the domain range minus infinity to infinity, whatever the range of the pdf, cdf range always you have to take from minus infinity to infinity, and it should vary from 0 to 1, and is equal to you have to write on the left side only, is equal to you have to write on the left side only. In the pdf you have seen whether we have the is equal to or we haven't the is equal to, there is no problem. But in case of the cdf, always you have to write the is equal to, is equal to on the left inequality, is equal to on the left inequality, right? So this is the way to write the correct form, or in this is the correct way for writing the cdf. Now after having the knowledge of the cdf, what I have told you, we have to equate the cdf with the uniformly distributed number between 0 and 1. So in this case we have seen, in this case we have seen we got the constant at the two place. At this place we have the 1 by 4 for the x is equal to 0, and at this place we have the 1 by 2, right? So here I can say, here also I have the constant 1 by 4, and here I have the constant 1 by 2 at the is equal to, right? At the is equal to, it is the 1 by 2. It means fx can be written as, fx can be written as 0, 1 by 2, 1 by 4, 1 by 2, and 1. At this place we have the f1, at this place we have the f2, at this place we have the f3, is equal to u between 0 and 1, u between 0 and 1, right? So here we have the 0, here we have the 1, and we assume that, let here we have the 1 by 4, and here we have the 1 by 2, and at this place we consider the number u1, u2,
Sir,
un. Yes.
sir, your screen,
Screen
sir, your
is,
screen froze.
in my computer it is showing.
Sir, the video is not proper for us.
In my computer it is showing still, there is no video.
Sir, we are in the previous.
अच्छा ये फ्रीज हो रखा है, अच्छा अच्छा। So now it is visible.
Yes, sir.
So for the CDF, I have discussed the three very important points that fx should range from 0 to 1. For the x, it should range from minus infinity to infinity, and is equal to should come always on the left inequality. Then after what the scheme we have seen, always you have to equate the fx to the uniformly distributed number between 0 and 1. So fx is equal to u between 0 and 1. So fx, in the fx we have seen, we have the two constants, 1 by 4 and 1 by 2, right? We have the two constants, 1 by 4 and 1 by 2. So we can write the fx in this way: 0, 1 by 4, 1 by 2 and 1. And there in the intermediate we have the function f1, f2, f3. So it means 0 is equal to 0 when we are determining the 1 to 1 correspondence. So 0 is equal to 0, 1 is equal to 1. It means 1 by 4 is equal to 1 by 4, 1 by 2 is equal to 1 by 2. So corresponding to f1, we have the random number u1. Corresponding to f2, we have the random number u2. Corresponding to f3, we have the random number u3. So how we can generate the x? X as the inverse of the f, right, corresponding to u. So what it will give you? F1. F1 is what? F1 is the 1 minus x to power 4. 1 minus x to power 4 upon 4 is equal to u. Is equal to u, where u lie between 0 to 1 by 4, or you can say 0.25. 0.25. So it will give you x to power 4 is equal to x to power 4 is equal to, it will become the 1 minus 4u. 1 minus 4u. So x is equal to 1 minus 4u 1 by 4. But you know that and here u is what? U is between 0 to 0.25. 0 to 0.25. And in this range, in the PDF you have seen x is what? X is what? X is the negative. X is negative. It means in the fourth root, we have to take the negative root. Right? Here we have to take the negative root. For the range u from 0.25 to half, that is the 0.50. What the function we have? 1 plus x square by 2. Let this is equal to u. So 1 plus x square is equal to 2u. So x square is equal to 2u minus 1, or x is equal to root of 2u minus 1. Means for the range of u from 0.25 to 0.50. For the range u from 0.50 to 1. 0.50 to 1, it is the x by 2. And here we have the u3, you can say, or u. So x is equal to 2u. X is equal to 2u. It means what is the scheme? Scheme will be minus 1 minus 1 minus 4u.
Excuse me, sir.
Yes.
Excuse me,
What?
sir. Sir, in the range 0.25 to 0.5, 2u minus 1 would be negative, right?
Ek minute. Just I have to write. Well, just wait a minute. I will answer. It is the 2u minus 1. 2u minus 1 to power half, and this is the 2u for the u from 0 to 0.25, from 0.25 to 0.50, and from 0.50 to 1. So here also always you have to take the is equal to on the left side, left inequality. Yes, what you are asking now?
Sir, in u lie between 0.25 to 0.5, 2u minus 1 would be negative. So how can we take the square root?
अच्छा, तो हमने क्या गलती की है? एक मिनट, हमने ऊपर का फंक्शन गलत उतारा है क्या?
Sir, it will be
It
1
is the
plus x square by
1 by
4.
4. It is the 1 by 4. Now correct?
Yes, sir.
Any other doubt? So in this way, we can generate random variate x, right? Random variate x using the uniformly distributed random number between 0 and 1. One exclusive, 0 inclusive. That's why 0 inclusive is equal to on this side, 1 exclusive, on this side, which follow, right, which follow the this PDF, which follows this PDF. So in this way, we can generate the random variate which follow the given distribution. Clear? Let us have some more example. So that is written here, complete thing. Now, in continuous of that, if, for example, 2-digit random number is given to you, 37. Random digit always we give as like this. But when we have to use, you have to use between the 0 and 1. So 0.37. So 0.37. So when u is given to you as a 37, or you can take 0.37. So 0.37 lie in the second interval. So x will come 4 into 0.37 minus 1 power 1 by 2. So that is the value of x corresponding to random number 0.37. Right? So in this way, we can compute the random variate. Now, so this is the way to generate the general continuous random variable. Now, let us see how to generate the standard one. So in that, first one is the exponential distribution. So for the exponential distribution, you know various things. So now, means always for any distribution, first you have to write the scheme, how you are generating the random variate. So generation for exponential distribution. So when we say x follow the exponential distribution with parameter lambda. So you know what is the PDF? PDF is what? Lambda e to power minus lambda x for x greater than 0. And what is the CDF? Its CDF is standard 1 minus e to power minus lambda x for x greater than 0. And it is 0 elsewhere, right? It is 0 elsewhere. So I have told you, always we have to write the CDF for minus infinity to infinity. So here we have written for minus infinity to infinity, right? And it should range from 0 to 1 and is equal to, we should take on the left side. So here we have to write the is equal to on this side. So this is the CDF. Now what is the way to write? We have to write the fx is equal to u, which is uniformly distributed number between the 0 and 1, 0 inclusive, x exclusive, 1 exclusive. So fx is what? 1 minus e to power minus lambda x is equal to, let's say, u, any random number between 0, 1, let's say u. So it will become e to power minus lambda x is equal to 1 minus u, or if you take the logarithm on both sides, taking log on both sides. So when you take the logarithm on both sides, minus lambda x is equal to ln of 1 minus u. So x will come minus 1 upon lambda ln of 1 minus u. So this is the scheme to generate, right? And u must be between 0 and 1. So this is the scheme to generate the exponential variate using the random number between 0 and 1. It is some, I think, some blackout.
Yes, sir.
पता नहीं क्या हो रहा है यार, आज प्रीवियस क्लास में भी आज काफी डिस्टर्ब हुआ है. So x is equal, now it's clear now, what is okay?
Yes, sir.
Sir.
So x is equal to minus 1 upon lambda ln of 1 minus u. This is the scheme. So if u is uniformly distributed between 0 and 1, then what is the status of the 1 minus u? I'm saying that if u is between the, let it is the 1, it is the 0, it is the uniformly distributed, then what is the status of the 1 minus u? It is also uniformly distributed, right? It is also uniformly distributed. So here we have to write the uniformly distributed number. So this scheme can be rewritten as 1 upon lambda ln of u. Instead of the 1 minus u, you can replace this also. So this is the another way to write the scheme. Again, u must be between the 0 and 1. But very important thing, you have to take care that you can use only one. Means for the generation different variates, you cannot use sometimes this or sometimes that. Either for the complete problem you have to use the first one, or you have to use the second one, but you cannot use both continuously.
Sir, how have we taken 0 included?
Actually, 0 included always we have to take. Means here I am just demonstrating that u as well as 1 minus u both are uniformly distributed.
Sir,
So
but
either
that
you
1
take
will
the,
be included, but 0 will not be included, right?
no.
So
In
because
case of
log
the
of u is
simulation,
log of 0 is not
in
defined.
case of simulation, when we take the single digit random number, we take the 0 to 9. 0 to 9. When we take the two digit random number, we take the 00 to 99. Right? When we take the three digit random number, we take the 00 to 999. Never we take the 1. That's why 1 we cannot include. As we include the 1, right, it is the plus 1 digits.
But sir, how will we substitute 0 in this? Because log 0 is not defined.
Sure. Okay, that you are saying correctly. So here for this range, we have to write the U, uh, 0 open, 1 close. But here means in general we do not take the 0 or 1. In general, it is very rare we have the means I cannot say ki it will not come. It can come as a random number. So for this case, we have to avoid that 0. Right? So this is for the exponential distribution. So it is here written U is not equal to 0. In this it is written. Clear? Now here if you take mean mu is equal to 5, therefore lambda is equal to 1 upon 5. Now let us take the 5 arbitrary random values from the table 12. We have the table in the textbook of the random numbers. That is the table 12. Table 12 consists the random numbers. So random numbers we are taking from the page 61. Here the random numbers are 0.3 digit random number when we are taking. So it is the 0.380, 0.010, 0.217, 0.681, 0.719. So when we put this value, so you can use either formula. You can use the either formula of these two, but for all the 5 values, you have to use the same one. Right? You have to use the same one. So naturally, you will get the different x values or exponential variate, but corresponding to the given set of the random numbers. But you cannot mix the both formula. Right? You cannot mix the both formula here. So it is given to you. So corresponding values will come 1.03, 0.02, 0.53, 2.48, 2.75. Means what is the use? When I'm claiming that customers are joining the system with the mean rate 5 or with the mean time 1 by 5, right? Then or with the mean time 5 and mean rate 1 by 5, then the first customer will come at the 1.03, next customer will come at the 1.05, next customer will come at the 1.58, next customer will come at the 1.58 plus 2.48, and next customer will come the 2.75 plus 2.48 plus 1.58. So in this way you can say that without actual arrival of the customer, you can generate the customers using the random number. That is the benefit of the this simulation. Now, generation of the uniform random variable. So you know that if x is the if x follow the uniform distribution between a and b, between a and b, means let here we have the a, here we have the b, so this is the 1 upon b minus a. So fx is what? Fx is 1 upon b minus a for the x from a to b. So what is the its CDF? CDF is what? It is a 0 when x is less than a. It is x minus a upon b minus a. All the derivation we have covered in the initial part of the or introductory part of the probability theory. So x greater than a but less than b, and it is 1 for x greater than b. So here also the fx range from 0 to 1 for the x from minus infinity to infinity is equal to on the left inequality, right? Is equal to on the left inequality. What is the scheme? Fx is equal to u between 0 and 1, u between 0 and 1. So fx can take the value 0, 1. you can take the value 0 and 1. Means 0 is equal to 0, 0 is equal to 0. Intermediate x minus a upon b minus a is equal to the intermediate u. 0 is equal to 0, 1 is equal to 1, constant is equal to constant, intermediate is equal to intermediate. So x minus a upon b minus a is equal to u. So x will come a plus b minus a into u, and u lie between 0 to 1. So this is the scheme to generate the uniform variate. Right? With this scheme, you can generate the uniform variate. So all these things, we have the explanation. This is here we should have the is equal to. Right? So this is the scheme. X is equal to a plus b minus a into u. So let us have a question. Using the random number 0.775, generate one observation for the uniform random variable on 3, 10. So 3 is what? It is the a. 10 is what? It is the 10. So what is the scheme? X is equal to a plus b minus a into u. So a is given to you as a 3 plus b is given to you 10 minus a 3 into, always we can give the random number as a 775. Random digits as a 775, but when you have to use, always you have to use between the 0 and 1. So 0.775. Many times we do not give this decimal. We give only the 3-digit random number 775. So at the time of the use, you have to apply the decimal. So 0.775. So you will get the value 8.425. So in this way, you can generate the uniform variate. Let us have generate the random. This is the book example, unsolved example. Generate random variable from the PDF. Exercise 9.1a. Fx is equal to 1 upon 8, and x vary from -3 to 5. So here the fx is given to you 1 by 8 for the x from -3 to 5. So fx is what? Fx is minus infinity to x of fx into dx. So this is equal to, when x is less than -3 minus infinity to x, 0 into dx, that is the 0. When x is greater than -3 but less than 5, this will become minus infinity to x, or this will become minus infinity to -3 plus -3 to x, and this is equal to 0 plus -3 to x 1 by 8 into dx. So this will come 1 by 8 and x -3 to x. So this will become x plus 3 upon 8. X plus 3 upon 8, and when we put x is equal to 5, it is 1. This value is equal to 1. So when we have x greater than 5, so this will be the integration minus infinity to x, which can be written as minus infinity to 5 plus 5 to x. So it is equal to 1 plus 5 to x 0 dx. So it is equal to 1 plus 0, that is the 1. So in the fair form, when we write the fx, it will become 0 when x is less than -3. It is the x plus 3 upon 8. It is the x plus 3 upon 8 for the -3 to 5, and it is the 1 for the x from 5. So here also you can note that here we have the 0 to 1, here we have the minus infinity to infinity, and is equal to on the left side. So what we have to do, fx is equal to u between 0 and 1. So here we have the 0 1, here we have the 0 1, intermediate value x plus 3 upon 8, and here we have the u. So x plus 3 upon 8 is equal to u. So x will come 8u minus 3 for the u vary from 0 to 1. So this is the scheme to generate the uniform variate between minus 3 comma 5. Let us have this example. Fx is equal to 1 by 3 for the x between 0 to 1, and 2 by 3 for 1 to 2. It is given to you as a fx 1 by 3, 2 by 3 for the x, and it is 0 elsewhere, and range is given to you 0 to 1, 1 to 2. Zero to 1, 1 to 2. This is your fx. So from here, first we have to compute the CDF. What is the CDF? CDF is minus infinity to x fx into dx. So its value for the x less than 0, it is the minus infinity to x 0 dx, that is the 0. For the x greater than 0 but less than 1, this will become minus infinity to 0 plus 0 to x, and this is equal to 0 plus 0 to x 1 by 3 into dx. So it is the x by 3 0 to x. So it will give you x by 3. So when we put x is equal to 1, it will give you 1 by 3. When x is greater than 1 but less than 2, so minus infinity to x fx dx can be written as minus infinity to 1 plus 1 to x. For this range, it is the 1 by 3 plus, for this range 1 to x 2 by 3 into dx. So this is the 1 by 3 plus 2x by 3 1 to x. So it will become 1 by 3 plus 2x by 3 minus 2 by 3, right? Minus 2 by 3. So it will come 2x minus 1 by 3. So when we put this is the for the x greater than 1 but less than 2. So when we put x is equal to 2, this all are the rough work, right? X is equal to 2. So for the x is equal to 2, it will give you 1. For the x greater than 2, so for the x greater than 2, minus infinity to x will become minus infinity to 2 plus 2 to x. So here we have the 1 plus 2 to x 0 dx, that is the 1 plus 0, that is the 1. So from here if I want to write the fx in the fair form, so it is the 0, 1 for the x from minus 1 or 0, for the x less than 0, for the x greater than 2, it is the 1, and intermediate values are, it is x by 3 and 2x minus 1. So it is the x by 3 and 2x minus 1 by 3 for the x from 0 to 1, for the x from 1 to 2. So again you can notice here fx has the 0, 1 for the x from minus infinity to infinity and is equal to on the left side. So when we do the fx is equal to u between 0, 1. So here we have the 0, here we have the 1, here we have the 1 by 3, right? 1 by 3. So when we have the 1 by 3, in between we have the function x by 3, and here we have the function 2x minus 1 by 3, and here we have the u. For this we have the 1 by 3, 1 by 3, 0, 1 by 3 and 1. Here we have the u1, or here we have the u2. So this will give you x by 3 is equal to u, implies x is equal to 3u, and here we have the 2x minus 1 by 3 is equal to u. So this will give you x is equal to 3u plus 1 by 2. U vary from 0 to 1 by 3, and u vary from 1 by 3 to 1. So this is the scheme to generate, right? This is the scheme to generate the continuous random variate which follow the given distribution. So that's all from my side for today. So in next class we will study more distribution. So important thing is just you have to compute the proper CDF and you have to equate with the random number. So again we have the blackout. So just we are stopping the recording.